Guys, I'm back with a new video, and this video we're going to talk about backup and recovery using AWS. Past 2 weeks, I have been asked a couple of times about AWS backup and recovery, how it is done, what is available, and how you can take advantage of it. So this video is based on a public document um, from, as you can see it from AWS. We're going to talk about it like a high level concept of how you can simplify your current backup and recovery environment in this enterprise. And we will provide a lot of details. And as you can see, the following individual contributed to this paper. And this paper is available from AWS. And this is a public information. Please feel free to use this presentation any way, shape, or form you want. And a little bit about me. You can see my name is Raza Raymond, and I'm a solution architect with a lot of experience. And these are my certifications, so I'm not going to waste my time explaining this thing. So let's go to our next slide. And our next slide is why we need a backup and recovery in Azure, by the way. General assumption is, hey, when you move your infrastructure into the cloud, they are responsible. So why would you need a backup? And if you're running your infrastructure in the cloud, again, they are responsible. So these are the questions actually from the regulators, from the enterprise people. Like, hey, if we move our data or important data into the cloud, what will happen in case of disaster, and how we can retrieve it in terms of disaster recovery, and also as operational recovery. So as you can see with this slide, we're talking about the growth of enterprise data accelerate, the task of protecting it becomes more challenging. So questions about the durability and scalability of backup methods are commonplace, including this one. So let's say you have a database, 1 terabyte or 2 terabyte. What will happen if your company grow and it comes to a like 6 terabyte? How are you gonna back that data up? So this what we're talking about here is actually, this one we're talking about from a again, it's a knowledge perspective as well as a exam perspective as well. So this will give you some insight, knowledge, or information. How can the cloud help meet my backup and archival need? So this video going to cover a number of backup architectures like cloud native applications, hybrid and on-premise environment, and associated AWS services that can be used to build a scalable and reliable data protection solution. The concept we're going to talk about in this one is not only um, you know pointing to AWS. You can use the same concept if you are going to Google Cloud or Microsoft Cloud. So, but we're going to talk about AWS because that's my favorite topic. So, Amazon Web Services, known as AWS, is a secure, high performance, flexible, cost effective, and easy to use cloud computing platform. AWS takes care of a undifferentiated heavy lifting that provide tools and resources you can use to build a scalable backup and recovery solution. So guys, there are tons of backup and recovery software available, which you can leverage on your on-site or on-premise environment, and also on cloud as well. I mean, you have a Veeam, you have Zerto, you have Commvault, you have Avamar. So there are tons of solution available. So what solution we can use it, and actually without using any third-party solution, what we can do in AWS. So it's going to be native to AWS services. So why we want to use AWS? So AWS have a simple storage solution, which is a S3. Everybody knows we have a S3 bucket. They have a Glacier, which are designed for 99.99999, like 11 nines of durability for the object stored in them. So both platforms offer a reliable location for backup data. So, but you should know this thing like in S3, you can copy it and retrieve it right away. But in Glacier, once you move the data into the Glacier, it takes time to get it out. Sometimes the SLA is 3 to 4 hours. Security, which is a very, very important topic. So AWS provides a number of options for access control and encrypting data in rest and at rest. And also, if you are interested in AWS, you should know that the AWS has a shared responsibility model, meaning the customer is responsible and also the AWS is responsible too. So there are different areas of responsibility. And AWS has a global infrastructure, so its services are available around the globe. So you can back up and store data in one region that meets your compliance requirement. So the key is a compliance requirement. If you're living in Canada, Canada has a requirement. Hey, don't move our data out of the Canadian boundary. Or if you're in France, they have their own rules. So every country has their own rules. So depending upon your rules, you can decide where you want to back up and copy your data to from one region to another region. Talking about compliance, so compliance are pretty complicated things. So AWS infrastructure is certified for compliance with standards such as Service Organization Control, known as SOC, Statement on Standard and Attestation Engagements, SSAE, International Organization for Standardization, ISO, which is 27001, and there are more. And if you're accepting a payment using credit card, so they have a payment card industry data security standard, PCI DSS, Health Insurance Portability and Accountability Act, HIPAA, and SEC1, and Federal Risk and Authorization Management Program, FedRAMP. So you can easily fit the backup solution into your existing compliance regimen. So this thing is important if you are have a accepting the payments, or you are .gov, or you have a sensitive data, you have a research, and when you're storing data, there are compliance, there are requirement. So AWS provides you all this these standards. Now we're talking about scalability. So with AWS, you don't have to worry about capacity. You can scale your consumption up or down as you need. You need change without administrative overhead. I mean, let's say if you're saving your data on your local infrastructure, let's say you have a 2 terabyte drive or 10 terabyte drive, there's going to be a time when you're going to be out of space. So then you have to buy, So in this case, or if you're saving a data and your disk drive goes bad, then you're in trouble. So this way, if you're using AWS, you don't have to worry about all these things. So right here is talking about a lower TCO. So lower TCO is a total cost of ownership right here. So the scale of AWS operation drives down service cost and help lower the total cost of ownership of the storage. AWS passes these cost saving on to the customer in the form of price drops. So as you, I mean, you can see like every few weeks or every month, Amazon is dropping prices. It's kind of hard to see nowadays that somebody's dropping prices, but Amazon is, and the other cloud providers are doing the same thing in order to stay in business. Otherwise, hey, nobody's going to use it. And also, Amazon provides hey pay as you go pricing. So pay as you go pricing is like you purchase AWS services as you need them, only for the period you plan to use them. So AWS pricing has no upfront fee, termination penalty, or long-term contract. Meaning, hey, come on, use our services. Don't like it, say yeah, no penalty, and no long-term contract. So it's win-win situation for everybody. So now we're talking about AWS storage services for data protection. So you have Amazon S3 and Amazon Glaciers are ideal services for backup and archival. Both are durable, low-cost storage platform. Both offer unlimited capacity and require no volume or media management as backup data set grows. What they're talking about, you sign up for the service, Glacier or S3 bucket, that's all. You have unlimited space and like pay as you go model, and the low cost per gigabit per month makes these services a good fit for data protection use cases. So they are giving you a bigger picture. If you take a bigger picture, like normally the S3 bucket is simply S3, like a folder, on your network drive basically, and that folder is available, like it's a unique in the entire AWS. And also it gives you other options, like you can enable versioning, and there are a lot of other services attached to it. So we just are focusing our attention right here to the data protection. And obviously, you can use S3 to store and retrieve any amount of data at any time from anywhere on the web. S3 store data as an object within a resource called bucket. So AWS Gateway and many third-party backup solutions can manage S3 object on your behalf. And I'm going to get back to that in a second. You can store as many objects as you want in the bucket, and you can write, read, and delete object in your bucket. Single object can be up to 5 terabyte in size. So single object means one file can be up to 5 terabyte. But remember, the overall, there is no limit. So when I'm talking about right here, where it says a AWS Storage Gateway and many third-party backup solution can manage. So there are software available off the shelf. You can buy it, and that software can manage your backup. They can back up from your server. You can install that piece of software on your server, and then sign up to AWS, or the third party will sign up on your behalf, and they're going to start copying your data from your location to AWS. You don't have to do anything. You don't have to hire a solution architect. You don't need to know anything about AWS. You just pay and buy that software, which is not very expensive, and you set it up one time, and as you go. And again, we're going to continue a S3. You can use Amazon S3 to store and retrieve any document of data at any time from anywhere. Um, you know, the Amazon S3 store data as an object within the resource called bucket, AWS Gateway. I think we talked about this thing. This is And the S3 standard for general purpose storage for of frequently access data. So now we're talking about, like, if you want to save some files to S3, and S3, you have a standard for general purpose storage where you can use data, frequently access data. And then you have a S3 standard infrequent access for long lived but less frequent data. So the difference is kind of pricing between the two, and the third is the Glacier for long-term archive. You archive it, forget it until you needed it. Because again, like I said before, once you archive it, that's fine. But you want to retrieve it, then there is a delay. You have to send a request, and they're gonna copy your data from the Glacier to S3 bucket, and then you will be able to download. And Amazon S3 also offer lifecycle policies. You can configure to manage your data throughput and its lifecycle. After a policy is set, your data will be migrated to a appropriate storage, and without any changes to your application. So basically, you are saving data. Let's say you have a 10 gigabit worth of file, like 100 files, let's say, and those files are no longer in use. So what you can do it, you can set the lifecycle policies. Hey, I'm using a standard general purpose storage, and I have to pay for it. So after a month or after 10 days, whatever time frame you choose, copy the data to a infrequent access, S3 bucket. So what's going to happen is the data going to move from here to infrequent access. So your price is going to go down. And then you can set another time like, hey, once I move the data for a infrequent access bucket, then after 30 days or whatever time you set, move it to the long-term Glacier. So you're gonna get a lot of deep discount. So and it's gonna be very very cheap. I don't know right now what the pricing is, but the pricings are available and continuously dropping. And you can check on AWS website for how long it's gonna cost. And right here we're gonna talk about Glacier. So what is Glacier? So AWS or Amazon Glacier is an extremely low-cost cloud archive storage device that provides secure and durable storage for data archiving and online backup. To keep cost low, Glacier is optimized for data that is infrequently accessed and for which retrieval time of several hours are acceptable. So that's the key actually. Your retrieval time of several hours are acceptable. So with Amazon Glacier, you can reliably store large or small amount of data for as little as 100 of cent, 1.007 per gigabit per month. And this price is, I don't know, by the time you're reading this, you're listening to this video or reading this article, it's going to be changed. So is per month a significant saving compared to on-premise solution. Amazon Glacier is well suited for storage of backup data as with a long or indefinite retention requirement and for long-term data archiving. Just want to let you know at this point, for example, in a health industry in the state of Florida and United States, if I'm not mistaken, they have a data retention requirement as a birth to death. I think plus 20 years or plus 10 years. I actually forgot. So basically, it's like 100 years to be on safe side. You have to keep the data. So and most likely nobody ever gonna need that, but you have to make it available on demand. AWS Storage Gateway. So that was Glacier. Before that it was S3 bucket. Now we're talking about Storage Gateway. So Storage Gateway will connect an on-premise software application with a cloud-based storage to provide seamless and highly secure integration between your on-premise IT environment and the AWS storage infrastructure. So basically, you have the data on your site, on your local site. You enable AWS Storage Gateway. So this will seamlessly copy your data depending upon your setting to the cloud. And in addition to your third-party gateways, the one we talked about, and connector, you can use AWS options like AWS Direct Connect, AWS Snowball, AWS Storage Gateway, and AWS Amazon S3 Transfer Acceleration to quickly transfer your data. So these are all transfer services, meaning if you have a AWS Direct Connect, your data will not travel over the internet. It will use a secure connection, which is like a dedicated line from your site to your nearest ISP provider's data center, and from there they run a dark fiber, which goes straight to the AWS connection. Snowball is basically if you have a lot of snow in your area, you can make a snowball. No, I'm just kidding. A snowball is a device you can rent it or from AWS, copy your data and send that snowball device to AWS, and they will transfer the data. The reason is for the snowball device is this way. Your customer used to send AWS with all sorts of devices, so they are kind of standardizing it. Hey, you know what? You can have this snowball, and now snowball. There are different versions of snowball. The original snowball has been improved, and I don't know you guys watched the reinvent or not. Now they have a kind of 16 wheeler truck the whole truck as a snowmobile. Not a snowmobile, a snowball. So you can bring the truck and you can copy all the data for whatever number of days or month you want, and then that they will move that whole container from your site to AWS and upload the data. And you have a gateways. Gateway, we just talked about it. And gateway is a virtual appliance you can download in your on your premise, and depending upon the settings, you can keep the most frequent access data locally, and not frequent access data to the cloud. There are a lot of options available. You can have a S3 transfer acceleration, and you can quickly transfer your data. And right here, we're going to talk about, hey, now we talked about the different features. Now, actually, we have to talk about designing a backup and recovery solution. That's where you're going to need a solution architect, unless you can do it yourself. It's not that difficult, actually. So when you develop a comprehensive strategy for backing up and restoring data, you must first identify the failure or disaster situation that can occur and their potential business impact. In some industries, you must consider regulatory requirement for data security, privacy, records, and retention, and blah blah blah. Right. So to make it simplify, it's like, let me go back to the previous slide and make it for example, it's a bank. For example, they're keeping your data. So what is their requirement? If they lose data, hey, your banking information, your money, not gonna be that accurate. Same thing is like your medical record, your stock, your credit card statement. I mean, there are thousands and thousands of different categories where you have to follow the regulatory requirement. Um, because as a consumer, as a user, I mean, as a customer, your customer, like your company's customer, they don't care. They will go and slide their ATM card. They want their money. But on the back end, as a institution or as a enterprise, a company, you have to follow all these things. And right here, when we're designing a backup and recovery solution, what do we need? Actually, I'm going to go back for a second. Right here, we're talking about disaster situation. Like, what do you want? Is it a operational backup? Hey, ooh, my server, my application crashed, and I need to retrieve the data or SQL Server data. Or you have to plan like, okay, what happened? Is the whole disaster happened? My entire infrastructure got wiped out. So, or like, hey, I don't have an internet access for, like, let's say for 2 days. So you have to actually, identify the failure, and based on that failure, how you want to design your backup. So designing a backup is always the 50 is the half part or 50%, and the 50% is a recovery solution. Okay, you have the data somewhere in the cloud. Now you need it. How long is it going to take? So normally, also they call this like RPO and RTOs, but that's a little bit different than what we talk about here. So right here, when we talking about the data, oh, here you go, RTOs and RPOs. The RTOs are recovery time objective, and RPOs are recovery point objective. Like, okay, if there's a disaster, how far back I can go to retrieve my data? Like, for example, you're doing a constantly accepting a credit cards, for example, and boom, something happened. So your backup was like 30 minutes old. So basically, you're going to lose those last 30 minutes worth of transactions. So that called your recovery point objective. Or you want to keep that to a minute, for example. If you want to keep to a minute, then your backup has to, your RPOs should be less than a minute or minute. And now, disaster happened. Now, okay, I want to get my data back, which was, or the transaction which was done like a minute ago. So that called the RTO. How long is going to take to get to that point? We know we have the backup, but how long is it going to take to get to that backup? That's your RTOs. And like a granularity to meet the RTOs and RPOs of the business. Now we're talking about a file level recovery for individual file got deleted, or we want to have a volume level recovery. The whole volume went down, your whole data store went down. or you have a application level recovery, your database, SQL database went down, or maybe some tables in it got corrupted, and you have a image level recovery. So you can create like a let's say, if I'm not mistaken, you have a SAN, for example, and you took the image, the whole image of the SAN, or you have a server, you took the image of the server. So that's we're talking about the image level recovery. Now we're going to go to the next section, and next section we're going to talk about backup, recovery, and archive approaches based on the organization of your infrastructure. IT infrastructure can broadly be categorized as cloud native, on-premise, and hybrid. Either you have a data which can go to the cloud, you can save data to the cloud, as a cloud native, or you just is on-premise. Hey, I'm running a Veeam backup and recovery software. It's all let me rephrase it. Yeah, I'm running a Veeam backup and recovery software, but that software also has a plugin which is a cloud native. So let me go to a different example. Let's say you're doing a Windows backup, for example. So Windows backup is done locally, but maybe I'm wrong, because there's also cloud backup for Azure. You can use the Windows, backup wizard kind of to copy data to cloud. So let's say you're manually copying the data, you know. So that's a totally on-premise. That's the application has no capability to move the data to the cloud. And hybrid, basically you have both options, cloud native and on-premise. Now we're going to talk about what is cloud native infrastructure basically. So this scenario describes a workload environment that exists entirely on AWS. So since we're talking about AWS, but this could be entirely on a Microsoft Azure or Google Cloud or any third party um, data center. So as the following figure shows, which we're going to show on the next slide, it includes the web server, application server, monitoring server, databases, and Active Directory. These kind of things is in kind of every enterprise environment. You will see all these things. So this is like if you're running all your services from AWS. So hypothetically, we're assuming you're running AWS. You should be running everything on AWS because that's the best solution. You can leverage many built-in features to meet your data protection and recovery method. So, like you can see, you have a cloud front, you have a what you call a net single sign-on, and guys, I always forget what WAF is. It's a web application firewall. So remember, whenever you see the web, you see the WAF, meaning it's the Windows. I'm sorry, it's the web application firewall, and you can see the web front end. This is the net running SSO. So this giving you a lot of options, like how your backup is done. This is your users. This is your route DNS53. This is your cloud front. From here, this is the static CDM. um, so this got two DMZ zones. Here are your batch server. This is your database slave. This is your database master. So slave means this is kind of read only at this point. Um, this is your notification coming, CloudWatch monitoring. This is your S3 bucket. So you can see this is the AWS native scenario. I don't think it's, and obviously you see this is the entire VPC, virtual private cloud. This is a private subnet. This is a private subnet. Um, I can go deeper, but we just scratching the surface actually here. We will cover some of these option in the future slides. So right here, if you see let me go back one. It's okay, right here. So now we're talking about EBS, Elastic. I mean, the snapshot. So Elastic Compute Cloud, which is the EC2 instance, basically, can use Elastic Block Store. That's what we call it, the EBS. So what EBS is, it's like a drive you can attach on demand, and the drive you can select the hardware, like is what how many IOPS you want. You want the SSD or non-SSD is your choice. It's kind of volume, and you can store data and access primary data, and you can take that EBS and you can create a snapshot and you can attach to a different machine, or you can the snapshot you can migrate to another region or availability zone. Once you have that snapshot, sky's the limit. You can do whatever you want to do. So you can use this block storage for structured data, such as databases, or unstructured data, such as files in a system on the volume. Basically, what they're saying, you can use this thing for a SQL database as well, or any kind of database, SQL or NoSQL. So Amazon EBS provides the ability to create a snapshot, which is backups, of any Amazon EBS volume. It takes a copy of the volume and places it in the Amazon S3 bucket, where it is stored redundantly in a multiple availability zone. The first snapshot is a full copy, obviously, of the volume. Ongoing snapshot store incremental block level changes only. So the key is a store incremental block level. So that makes it much faster. So this is giving you a general idea. Hey, you can use the EBS snapshot based protection. So, and why we want to use this one? Because this is a fast and reliable way to restore full volume data. If you only need a partial restore, you can attach that volume to the running instance under a different device name, mount it, and use operating system copy command. It copy the data from the backup volume to the production volume. It gives you a choice. You don't have to store the complete volume. You can store the partial volume, meaning what you need, you can get it. So AWS EBS Snapshot can also be copied between AWS regions using the AWS EBS Snapshot copy capabilities available in the console or from the command line, as described in the Amazon Elastic Cloud Compute Guide. You know, um, you can use this. I mean, they're talking about the guide. I did not include that user guide, but it's available on their AWS website. You can use this feature to store your backup in another region without having to manage the underlying application technology. So as you know, the regions are, we in United States, we have a East region, we have a West region. Um, there are several regions around, and there are a lot. I don't know how many regions are around the country. You can copy actually data from New York to Japan, or you can copy data from Japan to Scotland or England, because the regions are coming up. Uh, as soon as Amazon is able to build the data center. And again, each region has a multiple data center. So it's not just one region means one site. It could have a 3 sites, 4 sites, depending upon the location. So right here, we're talking about creating EBS snapshot. You can create a snapshot. You can protect your data directly to double click. Double click, double disk based storage. You can use the AWS management console, the command line interface, or the API to create the EBS volume snapshots. So they're giving you a lot of things how you can create the EBS volume once you know what is the EBS volume. In the Amazon EC2 console on the Elastic Store Volume page, choose Create a Snapshot action menu. On Create a Snapshot dialog box, choose Create to a snapshot you will restore in the AWS 3. This is actually kind of strange at this point. You might not understand, but once you're in the console, just click, 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 and you're done. And right here, they're talking about the console they were talking about, the create a snapshot, and right here, and you're done. This is pretty self-explanatory. And right here, if you want to use the a command line, run a simple AWS EC2 create a snapshot. Boom, you're done. You can schedule and run the AWS create a snapshot command. Basically, say you want to take a snapshot whatever number of hours you want after, like in the morning, in the afternoon, in the night, and boom, it will create it. You can schedule it. The economical pricing of AWS S3 makes it possible for you to retain many generations of data. And because snapshots are block-based, you consume space only for data that is changed after the initial snapshot was created. So if you have a 1 terabyte data in original snapshot and the next snapshot, it changes only like 5 kilobyte. So it's just going to use the 5 kilobyte for because the block level. So this way, it's not like you got a 1 terabyte, one snapshot, and another terabyte after that, another terabyte after that. No, so this makes it very economical. So now we're talking about now we learn about what is EBS, how we can um, back up that and the snapshot, and now how can we restore from the snapshot. So to restore data from a snapshot, you can use the AWS management console or CLI, which is a command line interface, or APIs, basically application programming interface, to create a volume from an existing snapshot. For example, follow these steps to restore a volume to an earlier point in time backup. Use the following command to create a volume backup, a snapshot. So here you go. What region to what region? How you region US West 1B snapshot ID, my snapshot ID. So you're done. Restoring from a snapshot, continue. Um, on the Amazon EC2 instance, unmount the existing volume. In Linux, use unmount. In Windows, use the logical volume manager. And then go to use the following command to detach the existing volume from the instance. So right here, you run it. So I think we are getting too technical actually. Um, See, now it's talking about use the following command to attach volume was created and remount the volume running the instance. So this is more kind of practical. So if you have a console, you can have this video in front of you, and then, or the original article, and then you can follow these things because you can't remember this thing. I mean, honestly, I cannot remember this command unless I do this thing every day. You know, uh, so just to have a reference, and only when you need it, you can use it. So now we're talking about creating consistent or hot backup. So when you perform a backup, it is best to have the system in a state where it is not performing any I/O. In the ideal case, the machine is not accepting traffic, but it is increasingly rare as 24 by 7 IT operation become the norm. For this reason, you must quest the file system or the database in order to make a clean backup. This way in which you do this depend on your database or the file system. So what we're talking about here is, let's say you have a web server and it's continuously accepting the transactions. If you take a backup, then some transaction is going to be partially saved. You still filling your information on the form, you didn't hit the save, or you hit the save one form and you're waiting for the next form to fill out more information. So if the backup is done at that time, it might not save all the information because some information is still going to be in the memory. It's not written to the hard drive. So that's why we do the questing. What questing does it is actually go and you know uh, get all the information, including from the memory, in a nice way. Creating consistent or hard backup. So for this reason, you must quest the file system or database in order to make a clean backup. Um, So what they say, the process of database follow. Again, I think we're getting too technical, but let's do it anyway. If possible, put the database into a hot backup mode. Run the Amazon EBS Snapshot command. Take the database out of the hot backup mode. If using a read replica, terminate the read replica instance. The process for a file, all right here. So if the read replica says a terminate instance, basically you can create a read replica, so you're not taxing your production database. And once you're done taking the snapshot, and then you can delete the read replica. The process for file system is similar, but depend on the capabilities of the operating system or the file system. For example, XFS is a file system that can flush its data for a consistent backup. So creating a consistent hard backup continue. If your file system does not support the ability to freeze, you should unmount it, issue the snapshot command, and then remount the file system. Alternatively, you can facilitate this process by using a logical volume manager and unfreezing of IO. I tell you what, if you are responsible setting up a backup using this document or this video, then you should know what what we're talking about, a freezing or unfreezing, because that's pretty basic. Because the snapshot process continue in the background as the creation of the snapshot is fast to execute and capture the point in time, the volume you are backing up only need to be unmounted for a matter of seconds. Matter of seconds, I don't know you guys were watching the Star Trek or not. They said the fraction of second in Androids live is eternity. That was the coming from data, the tenant data. So matter of second could be just second, or it can create a problem. So depending upon the software. Because the backup window is as small as possible, the outage time is predictable and can be scheduled. Yeah, I would say this is the sales pitch. You may agree to disagree, but or you can totally disagree. It's your call. But you know, uh, there are um, information where that does not apply or does not fit, like for all scenarios. So in some cases, yeah, I want to go back for a second. Like if you have Exchange server and you took a snapshot, it's gonna disconnect all of your Outlook clients right away. Yeah, you will not know because you're running Outlook in the caching mode, but it might do it. Now you're talking about the multi-volume. So in some cases, you can strip data across multiple AWS EBS volumes by using a logical volume manager to increase potential throughput. Increase potential throughput. Okay. When you use a logical volume manager, for example, a MDADM or LVM, it is important to perform the backup from the volume manager layer rather than underlying EBS volume. This ensures all metadata is consistent and the subcomponent volumes are coherent. Performing a multi-volume backup, there are a number of ways to accomplish this. For example, you can use the script created by alestic.com.5. And that 5 means it's a reference in the download document. Um, Sorry. Um, the memory buffer should be flushed to the disk. The file system I/O to disk should be stopped, and the snapshot should be initiated simultaneously for all the volumes making up to the rate set. After the snapshot for the volume is initiated, usually a second or two, the file system can continue its operation. The snapshot should be tagged so that you can manage them collectively during restore. Again, I think we're getting a little bit too deep here, but you don't have a choice. Okay, guys, so you can perform these backup from a logical volume manager or file system level. In these cases, using a traditional backup agent enables the data to be backed up over the network. A number of agent-based backup solutions are available on the internet and in the AWS marketplace. And right here again, I apologize for the 6 because this is the reference in the document. Remember that the agent-based backup software expect a consistent server name and IP address. As a result, using these tools with instance deployed in the Amazon Virtual Private Cloud (VPC) is the best way to ensure reliability. An alternative approach is to create a replica of the primary system volume that exists on a single large volume. So what they're saying is if you have multiple volume, you can to create a replica of that multiple volume to a single volume. And then this simplify the backup process because only one large volume must be backed up. and the backup does not take place on the primary system. However, you should first determine whether the single volume can perform sufficiently during the backup and whether the maximum volume size is appropriate for the application. Here, actually, I think the AWS is trying to sell with this method more services because instead of backing up directly from the multi-volume device, you have to create a single large volume. So here you go. Hey, I'm just giving you my honest opinion. Um, AWS has many options for databases. You can run your own database on EC2 instance, or you can use one of the managed services databases option provided by AWS, or I'm sorry, Amazon Relational Database Services, Amazon RDS. If you are running your own database on EC2 instance, you can back up data to file using native tools, for example, MySQL, Oracle, MySQL, and PostgreSQL, or create a snapshot of the volume containing a database. One of the method described in EBS snapshot based protection. So this is for actually a SQL. So the key is you get from this slide, hey, you can back up the databases, and there are many ways to do it. And when you get to this one, you will know how to do it. And here is you can create a database replicas backup, and you can back it up from there. So for databases that are built on RAID sets of Amazon EBS volume, you can remove the burden of backup on the primary database by creating a read replica of the database. So yes, you can remove the burden, but you are creating another replica. So you create a replica, it costs more, but not that significant. This is an up-to-date copy of the database that runs on a separate Amazon EC2 instance. The replica database instance can be created using multiple disks similar to the source, or the data can be consolidated to a single EBS volume. You get it? So creating a replica database and on a separate instance. You can then use one of the procedure described in EBS Snapshot volume protection. You can Google this thing. Oh, I'm sorry. You can go to AWS website and you can find this thing. It has a up-to-date information. The snapshot, the EBS volumes, to the snapshot to the EBS volume basically. This approach is often used by large databases that are required to run 24/7, like eBay, for example. I think eBay runs on Oracle. Uh, when what is the case, the backup window required is too long, and then production database cannot be taken down for such a long time. So basically they are saying it has a large database run 24/7, or whatever the maintenance window, the backup window is not large enough because of the size of the database. Using AWS RDS for backups. So Amazon RDS includes features for automating database backups. Amazon RDS creates a storage volume snapshot for your database instance, backing up the entire DB instance, not just individual databases. So what they're saying is you can create for the entire DB instance instead of like a giant one instead of individual databases. That's your another option. And you can see the font becomes smaller because we're talking about more approaches here. So the Amazon RDS provides two different methods for backing up and restoring your DB instance. Now we're getting serious. So automated backups enable point-in-time recovery of your DB instance. Automated backups are turned on by default when you create a new DB instance. Amazon RDS platform as a full daily backup. Okay, Amazon itself, RDS, performs a full daily backup of your data during a window that you define when you create the data backup in conjunction with your transaction log to enable you to restore your database to any second during your retention period, up to the latest restorable time, typically the last 5 minutes. Wow. So these are the automated backups. To find the latest restorable time for your DB instance, you can use the describe DB instances API call, or look onto the description tab for the database, Amazon RDS console. So you have to dig more on this one. When you initiate a point-in-time recovery, transaction logs are applied to the most appropriate daily backup in order to restore your DB instance to the time you requested. See, same thing is with the Exchange, Microsoft Exchange, and same thing with a DB. They create a logs. So with the help of logs, you can actually go back in time. If your backup is like 10 o'clock and then 10:30, what happened if your database is not available between, let's say, on 10:15? So hey, so you have to go back 10 o'clock. So so instead of losing the 15 minutes, you can use the transaction logs if you back those one up or you ship somewhere. You can go back to any point of time between 10 to 10:15. DB snapshots are user initiated that enable you to back your DB instance to a non-state as frequently as you like, and then restore to the state at any time. You can use the Amazon RDS console or API call to restore a DB snapshot. These snapshots have unlimited retention. They are kept until you use the console or the snapshot API call to explicitly delete them. So what they're saying it, hey, once you take it, it's going to be there forever, unlimited retention. So that's the key to remember. The DB instances, you can create a DB snapshot, and they stays forever. When you restore a database to a point in time for or from a DB snapshot, the new database instance with a new endpoint will be created. In this way, you can create multiple databases instance from a specific DB snapshot or point in time. That's kind of self-explanatory. You can use the AWS Management Console or delete DB instance call to delete the old database. Remember to delete it, otherwise it's gonna be you have to pay for it. Using AMI to back up EC2 instance. So here you see a little diagram. So right here, AWS stores system images, what you call Amazon Machine Images, AMIs. These machines consist of the template for the root volume required to launch an instance, like a C drive, boot drive. You can use the AWS Management Console or the AWS EC2 create image CLI command to back up the root volume as an AMI. So now we're talking about not taking the snapshot. Actually, you are creating a AMIs like a machine, the entire machine. So you create a template for the root volume. You register AMI, deregister, launch the instance or copy. So that's another option, creating an AMI instead of the So right here we're talking about the using AMI to back up EC2 instance. When you register an AMI, it is stored in your account using Amazon EBS Snapshot. These snapshots resides in AWS S3 and are highly durable because they give you a 99.99999, like 11.9. So I don't think you guys can see this thing here, but this is kind of create an image. Um, you know, it's kind of, I'm sorry, I cannot do anything to make it larger, but you get an idea. Using EC2 console to create a machine image. And right here, we're talking about the backup EC2 instances. The same thing. After you have created an AMI of your Amazon EC2 instance, you can use the AMI to recreate the instance or launch more copies of the instance. You can also copy AMIs from one region to another region for application migration or disaster recovery. So you need this information actually when you are selling the solution to your bosses or to your customers. Um, you can tell them, hey, look, we can create an AMI and we can, for disaster recovery, we can migrate to another country. So it's going to be safe or another region. So on-premise to AWS infrastructure, I think this is the most important thing from my perspective because when you go to a customer or your company, that's the way you get in. Actually, hey, but I mean, you go there, you say, hey, by the way, hey, we can set up your on-premise to AWS infrastructure, and like little by little. So this scenario describes a workload environment with no component in the cloud. All resources, including web server, application server, monitoring server, database server, Active Directory server, and more, are hosted either in their customer data center or through co-location, like a local data center. So right here, they're talking about internet. There's a customer internet, right? Use the data center, the branch office, and co-location. So these are the three options. You can see it. So what you can do it actually. So by using AWS storage services, so you're getting your foot in. I say you're trying to set up a the you're trying to set up the backup to the cloud. You're just trying to sell it. So once that part is done, then easier to sell the other services. So by using AWS storage services in this scenario, you can focus on backup and archiving tests. You don't have to worry about storage scaling or infrastructure capacity to accomplish the backup test. Amazon S3 and Amazon Glaciers are natively API-based application programming interface. Basically, you can write a program code and you can talk to the Glacier and S3 and available through the internet. And there's nothing special. You don't need any VPN or you know direct connect. Um, This allows backup software vendor to directly integrate their application with AWS storage solution as shown in the following figure. So right here, this is your the backup server. This is your infrastructure backup server. It goes to the S3 and this AWS, and then it's got we talked about it, the life cycle policies, and move it to the Glacier. So in this one, we're talking about on-premise to AWS infrastructure continue. In this scenario, backup and archival software directly interface with AWS through the API. Because the backup software is AWS aware, it will back up the data from the on-premise server directly to the S3 or Amazon Glacier. If your existing backup software does not natively support, so this is the key point here, guys. If your backup software does not natively support the AWS cloud, you can use AWS Storage Gateway product. You can download the virtual machine basically, and then AWS Gateway is a virtual appliance that provides seamless and secure integration between your data center and the AWS storage infrastructure. And this service allows you to securely store data. So this option actually, you can sell it to the customer, hey, even and without changing their existing backup software. You know, and to me, I think this is a very, very, very cool feature. So on-premise to AWS infrastructure. So in the AWS cloud and scalable and cost-effective storage gateway support industry standard storage protocol that work with your existing application while securely storing all of your data encrypted in AWS S3 or Amazon Glacier. So guys, here's the key in this one is data encrypted. So whatever data is going to the cloud is encrypted. So same thing. This one was a AWS. So see, this is the AWS Storage Gateway. It creates this the network disks, and using the SSL goes to AWS Storage Gateway service on a Amazon site. Then goes to S3. From S3, it can go to a EBS volume, and then it can go back and forth to your compute cloud. They can access the data. On-premise to AWS infrastructure continue. AWS Storage Gateway support the following configuration. So now we're talking about configuration, what is supported. So it's supported is a volume gateways. The volume gateways provide cloud-backed storage volume that you can mount as internet small computer iSCSI devices from your on-premise application server. Guys, if you don't know what iSCSI is, just stop it right here. Because the assumption is whoever is implementing this thing, he should know iSCSI. The gateway support the following volume configuration. Number one is gateway cached volume. The other one is the gateway stored volume. So gateway cache volume, you can store your primary data in AWS and retain your frequently accessed data locally. So gateway cached volume provides substantial cost saving on the primary storage, minimize the need to scale your storage on premises, and retain low latency access to your frequently accessed data. So guys, I'm not sure if you guys know the hyperconverge or not. If you're using the hyperconverge or some the the storage, they have a regular disk and SSD disk. So whatever the most frequent data is, the data is moved to the SSD drive, so it's fast in accessible. So same concept is here actually. The most frequent data are going to stay local, and the data is not is going to be cached. It's going to be cached local gateway cache volume. So and the rest of the data are going to be in the cloud. So whatever data you need to access that can get copied from the AWS to local. So this way, you have a lot of saving. Gateway stored volume is the second option. In the event you need a low latency access to your entire data set. So the difference is here is only a frequently accessed data locally. Here is the entire data set is here. You can configure your on-premise data gateway to store your primary data locally and asynchronously backup point-in-time snapshot of this data to S3. So the key is asynchronously. It's not synchronous. So basically, if your data, local data, get changed, it's not written simultaneously to the cloud. So it's going to be copied to the cloud on your scheduled time. So gateway stored volume provide a durable and inexpensive offsite backup that you can recover locally or from AWS EC2. So this is kind of pretty good options with a lot of saving. Um, okay, this infrastructure continue. The Gateway Virtual Tape Library is another option. Gateway VTL. With Gateway VTL, you can have a limitless collection of virtual tapes. Each virtual tape, remember, it's not a tape, it's a virtual tape. So each virtual tape can be stored in a virtual tape library backed up by S3 or a virtual tape shelf backed up by Amazon Glacier. So we're talking about Glacier shelf and a virtual tape right here. The virtual tape library exposes an industry standard iSCSI interface, which provides your backup application with online access to the virtual tapes. When you no longer require immediate or frequent access data contained on your virtual tape, you can use your backup application to move it from the virtual tape library to your virtual tape shelf to further reduce your storage costs. So it's all about saving and options. So these gateway act as plug-and-play devices providing standard iSCSI devices, so no special drivers are required, which can be integrated into your backup or archive framework. You can use the iSCSI disk devices as storage pools for your backup software or the gateway virtual tape library to offload tape-based backup or archive directly to AWS S3 or Amazon Glacier. Using this method, your backup and archives are automatically offsite for compliance purposes, of course, and stored on durable media, eliminating the complexity and the security risk of offsite tape backup management. And now we're talking about hybrid environment. So the two infrastructure deployment discussed to this point, the cloud native and on-premise. Now we're talking about, okay, on-premise can be combined into a hybrid scenario where the workload environment has on-premise and AWS infrastructure component resources, including web servers, application server, monitoring servers, database, Active Directory, and more are hosted either in the customer data center or AWS. Application running in AWS clouds are connected to applications running on-premise. Hybrid. So this is becoming a common scenario for enterprise workload. Many enterprises have data center of their own and uses AWS to augment capacity. These customer data centers are often connected to AWS network by high capacity network link. For example, with AWS Direct Connect, hey, I want to mention this thing for AWS is Direct Connect, and for a Microsoft Azure is a Express Route, which is the same thing, same concept. You can establish private dedicated connectivity from your premises to AWS. This provides the bandwidth and consistent latency to upload data to the cloud for the purpose of data protection and consistent performance and latency for your hybrid workloads. Okay. And well-designed data protection solution typically use a combination of this method described in the cloud native and on-premise solution. So this is kind of a hybrid. Same thing as a CloudFront, Route 53. That's your, www.sensor.com. These are the user. These are the other services to going to the corporate data center, and this one going to the AWS. So this is a on-premise. This is the one is the cloud. So this becomes hybrid, and right here your AWS is directly connected to your on-premise. This is the high-speed internet connection on the connecting these two things. So uh, these are the infrastructure server, application server, database, web server, storage, and right here database, application server, web server, infrastructure server. And you're not going to see the storage because this is all handled by um, AWS, right? You will see the VPC is virtual private cloud. That's why you see the cloud, and this is the gateway. I'm just giving you the kind of details. I'm pretty sure you guys know what I'm talking about. And guys, few more slides left. So let's go backing up AWS based application to your data center. Now we're talking about AWS based applications. So if you already have a framework that back up data for your on premises servers, then it is easy to extend it to your AWS resources over a VPN connection or through AWS Direct Connect. You can install the backup agent on the AWS EC2 instances and back them up per your data protection policies. Migrating backup management to the cloud for availability. Depending on your backup infrastructure or architecture, actually, you may have a master backup server and one or more media or storage devices located on premise with these services with the services it's protecting. So, and that's a very, very common scenario actually. Yes, every organization has a backup server located on premise. So in this case, you might want to move the master backup server to Amazon EC2 instance to protect it from on-premise disaster and have a highly available backup infrastructure. See, this one is awesome actually. So what you're doing it, you're taking your main server as is, moving it to the AWS, and having a VPN connection from AWS to your own site, and nobody will know that the master server is no longer available on premise. In fact, it just got moved to the cloud, and everything is back to. I mean, as usual. Obviously, the cost a little bit, but other than that, it's pretty genius solution. To manage backup data flow, you might also want to create one or more media servers on Amazon EC2 instances. Media server near the Amazon EC2 instances will save you money on internet transfer and backing up to S3 or Amazon Glacier, increasing overall backup and recovery performance. So I think the media server probably are the one which do a, deduplicate, copy the data. So that's way it will save you money in the bandwidth. So that's what they're talking about, using gateway in the hybrid scenario. So again, this is the AWS, this is the colo location, this is your branch office, this is your data center. So right here, this thing was backed up here. So from here to here is going right here. Corporate data center, server infrastructure, storage gateway. See, we put the storage gateway right here, storage gateway right here, storage gateway right here. So we put the storage gateway in all three locations, and they are communicating to the AWS. So you don't need, the on-premise infrastructure to back up. So now is the example of hybrid scenario, and this is so tiny. I apologize if you cannot read this thing. So let's see. Assume that you are managing an environment whether you are backing up Amazon EC2 instances, right? A standalone server, virtual machines, and databases. The environment has 1,000 servers, and you back up the operating system, file, data, virtual machine, images, and backup. There are 20 databases, a mixture of MySQL, Microsoft SQL Server, and Oracle to backup. So that's a pretty complicated scenario, right? And you know what? The idea making this video came from the question someone asked me exactly the same thing. The question was, you are running 1,000 server, the load consists of on many different scenario. I mean, there are many different applications like the one is described here. How will you do backup? So to protect this environment, use third-party backup software. Most likely has a global catalog server or master server that controls the backup, archive, and restore activity, as well as multiple media servers that are connected to the disk-based storage. Um, Linear tape open LTO, tape drive, and AWS storage services. The simplest way to augment your backup solution with AWS storage is to take advantage of your backup vendor support for Amazon S3 or Amazon Glacier. We suggest you work with your vendor to understand the integration and connector option. For a list of backup software, you can go to partner directory on the link I provided in the first slide or second slide. You can click on number 15 and it will give you a more, or you just can go to their website. If your existing backup software does not natively support cloud storage for backup or archive, you can use the storage gateway device such as bridge between the backup software, Amazon S3, and Glacier. So I think we are just whatever we discussed in the other two scenario, cloud native and on-premise. So this hybrid is mixed, both of them. So there are many third-party gateway solutions. You can use AWS Gateway virtual appliances to bridge this gap because it uses generic techniques such as iSCSI-based volume and virtual tape library. The configuration require a supported hypervisor, VMware or Microsoft Hyper-V, and a local storage to the host appliances. Um, okay, the two major hypervisors are supported. I'm not sure about the Acropolis or KVM. So archiving data with AWS Continue, when you need to preserve data for compliance or corporate reason, you archive it, unlike backup, which are usually performed to keep a copy of production data for a short duration to recover from data corruption or data loss. Archiving maintains all copy of data until the retention policy expires. This thing I have dealt with this thing several times when you have Exchange server, for example, and you got sued by some company about, hey, we send you this thing, you didn't do it, or you didn't reply. So in that case, if there's a dispute, they put a like a hold on your data. Normally, it's on exchange-based exchange, but the concept is same. A good archive meet the following criteria: data durability for long-term integrity, data security, ease of recoverability, and low cost. Um, Immutable data stores can be another regulatory or compliance requirement. So archiving data with AWS continue here again, and a Amazon Glacier provide archives at low cost. Native encryption of data at rest, 11 nines of durability, and unlimited capacity. Guys, I want to tell you this thing here. Amazon Glacier provide low cost, yes, 100% correct. But if you save something to a Glacier and you need to retrieve it, you cannot retrieve it directly. That's my understanding. It you have to retrieve it. Whatever the SLA is, 3-4 hours, it's going to save it to a bucket, and from the bucket you're going to download on your on premise, and that's going to cost extra because the data egress data is not included. How much it's going to cost? I don't know. So Amazon S3 standard, which is a infrequent access, is good choice because Amazon give you S3 two choices. It's a general purpose and infrequent access. Is cheaper actually. And Glacier is a good choice for use cases where data is infrequently accessed and retrieval time of several hours acceptable. Okay. Objects can be tiered into Amazon Glacier either through lifecycle rule and S3 or Amazon Glacier APIs. Glacier's APIs. Okay. Amazon Glacier Vault Lock feature allow you to easily deploy and enforce compliance control for individual Amazon Glacier result with a Vault Lock policy. You can specify controls such as write once, read many, warm, and a Vault Lock policy, and lock the policy from the feature edit. So this is features. Just the one slide away to be done with this video. Now we're talking about securing securing backup data in AWS. So data security is common concern. Everybody gonna ask you this thing. So AWS takes security very seriously. We know that based on the share model. It is the foundation of every service we launch. We launch means the AWS launch. The storage services like Amazon S3 provide strong capabilities for access control and encryption both at rest and in transit. All Amazon S3 and Amazon Glacier APIs endpoints support SSL encryption for data in transit. Amazon Glacier encrypt all data at rest by default. So the key is by default. Even if you choose or not, that data is encrypted. With AWS S3, customer can choose server-side encryption for object at rest by letting AWS manage the encryption keys, providing their own keys when they upload an object, or using AWS Key Management Service, AWS KMS, which is again here's a 16 because on the document you're gonna see a link 16 for more information. Integration of the encryption key. Alternatively, customer can always encrypt their data before uploading into AWS. For more information, you can go review the overview of the security process. And now with the last slide is conclusion. Gartner has recognized AWS as leader in public cloud storage services, no doubt. AWS is AWS is well positioned to help organizations move their workload to cloud-based platform. The next generation of backup, AWS provides cost-effective and scalable solution to help organizations balance their requirement for backup and archiving. These services integrate well with technology you are using today. So guys, these are total, I think almost hour 20 minutes and a 59 slides. And like I said, this slide is free to use it in any way, shape, or form you want. There is no copyrights because this is actually owned by AWS. So feel free to use it. And in a side note, if you like this video, please subscribe to my channel. So this way I can create more video, and I will create more video. And thank you very much. And I appreciate for your time, taking the time to read this thing or listen to this thing actually. Thank you. Bye.